Welcome to the VirtusLab webinar today. Thanks for joining us this afternoon. My name is Peter Ratcliffe. I'm helping to host this along with Paweł Marks, who's one of our Scala experts, a leader in our Scala compiler team and a major contributor to Scala open source. Just a little bit of a summary about VirtusLab. You know, we've been around for 12 years. We've been working as a strong partner in software development, and we possess a lot of experience in key areas such as custom software development and cloud native services. And we are typically always looking to share our knowledge and looking to help the technology community get better at what they do and advance themselves. And I'm happy for everyone here to be participating in this event. So thank you very much. I'm going to hand over quickly to Paweł Marks, who the guy you're here to see. Again, if you need to ask questions, there is a QA button at the bottom of the screen. If you pop those questions into that QA, we'll then try to get them answered at the end of the webinar. And clearly, if you've got more questions or what have you, feel free to reach out after the event. And just to let you know, this is being recorded, so we'll be able to send a link out to you. So without further ado, I'd like to hand over to Paweł, and thanks for that.
So, hello and welcome. I am Paweł Marks from VirtusLab. And who are we? We are the company behind Scala Free. We are the maintainers of Scala Free compiler, and we are heavily invested into Scala tooling. We've created tools such as Scala, so the official documentation engine for Scala Free language, the Scala CLI, the easy-to-use command line tools for quick scripting and prototyping on Scala 2 and Scala Free code, the Inquire, the search engine that allows you to search for Scala documentation using function signatures as a queries. And also was not created, but we are contributing to it. We are developing and maintaining it, the methods. So the official language server for both Scala 2 and Scala Free. Who am I? I used to introduce myself as a developer that is passionate about compilers, tooling, and really everything that makes developers more efficient. Shortly after the initial release of Scala 3.0, I became a person responsible for future releases of Scala compiler. So you can probably know me from blog posts announcing new compiler versions and new features. And right now, I am leading the Scala 3 compiler team. You can find me on Twitter and GitHub under the handle Cordian, and I also registered this handle on Fosstodon. I am not active here yet, but probably I should be soon. So, what is Scala Free, the topic of today's webinar? It is a programming language that has a premiere a year and a half ago. It was before that, it was developed by Martin Odersky and his team at EPFL, under the codename Doti. It is the language that is designed to be a successor language of Scala 2. So it follows the same philosophy and the same design principles as Scala 2, but mitigates lots of Scala 2 shortcomings. It is generally more expressive and more intuitive language. But is it a good language for your company, for your project? To help you decide, I prepared for you this simple comparison between Scala 2 and Scala Free. Here we have 10 categories, from compatibility guarantees through compilation speed to hiring opportunities. All these categories decide on effectiveness of your developers and sometimes even or success or failure of your project. So let us dive right into it. First, we have compatibility guarantees. So Scala 2 was quite infamous in terms of compatibility guarantees. What I'm saying here, let's imagine that we go back in time a few years and Scala 2.12 just released. We have a project in Scala 2.11 And we are reading the changelog of Scala 2.12, and we see some really cool features that we know would help us in our project to better organize our code, to be more productive. Can we just switch Scala 2.11 to Scala 2.12? No, because we have Scala 2.11 dependencies. And in Scala 2 world, it was widely known that if you have a project in Scala 2.12, you need to have all your libraries, all your dependencies published to Scala 2.12. You cannot use 2.11 dependencies. So we need to wait for all of our dependencies, all of those libraries, to be first published on 2.12 before we can migrate to 2.12. But those libraries has exactly the same problem. They have their own dependencies, and they need to wait for their dependencies to be published on 2.12. So as you can see, even the single library that is widely used, that for some reason not migrated to the new version of Scala, can block the migration for the entire ecosystem for months. Not perfect. So we've waited a few months, and now let's imagine all of our dependencies are finally published to Scala 2.12. So can we just change the compiler version and be happy with that? Sometimes no. Sometimes after changing the compiler version, our code just stopped compiling. We need to read every error, go through every one of them, and see what's going on. Sometimes it was like a really simple tweak is needed in some place, so our code is compiling and working again. But sometimes, maybe those were rare cases, but they were there. Sometimes we need to rewrite some bigger parts of our system to be able to use a new compiler. So in Scala 2 words, changing the version of the compiler was a nightmare. How it looks like in Scala 3. In Scala 3, we are guaranteed full backward compatibility between minor releases. What I mean by that? It means that if we have some module compiled with some version of the compiler, it can be used by modules compiled with this version of the compiler and every future version. So, for example, the libraries compiled with Scala 3.0 can be used by projects using Scala 3.0, 3.1, 3.2, and any other future version. Moreover, we offer full backward and forward compatibility within the minor releases. So, if you are using Scala 3.0, you can use as a dependencies modules compiled with 3.1. Those versions are mutually interchangeable. And so we know that you no longer need to wait for your dependencies to be up to date with the new release of the compiler. But what with source compatibility? To solve that issue, we have the powerful tool called Open Community Build. This is something that is run every weekend and after every release candidate of new versions of the compiler. And what it does, it takes the entire Scala open source ecosystem. And by that, I mean the entire ecosystem. Every library that has its source code published and conforms to few very simple criteria is compiled, and we see if there are no new compilation errors. If there is even one new compilation error, that means there is something wrong with the compiler. So we are investigating that to be exactly sure that your code will never stop compiling. And if there is a case that it started compiling, that means that the fact that it was compiling in the first place was a result of bug in the compiler. So yeah, so in Scala 3 world, changing the version of the compiler is nothing difficult. It's usually a no-brainer. But some people need to be much more conservative when they are thinking about their version. So, and they don't need to want to update often. They don't need to want to update really at all. So for them, we've prepared and we are applying something that is called LTS releases, so long-term support versions of the compiler. Those are versions that has a guaranteed support period of at least 3 years. By support, we mean they will receive patches that are bringing bug fixes and small quality of life improvements. By that, I mean better error messages, better linting, and things like that. all the builds of the compiler within the single LTS version will be forward and backward compatible with each other, so they can be swapped without any risk. Okay, so we now clearly see that if we are talking about compatibility guarantees, Scala 3 is already a clear winner over Scala 2. But let's examine other categories. So the second one I would like to talk about is modeling your business domain, because this is what we are mainly using our programming language for. So let me start by sharing the simple observation. If we look at the modern programming languages that gained popularity, in other words, gained traction in the last, let's say, 10 years, they have one thing in common. And it doesn't matter if we think about Kotlin, TypeScript, Swift, Rust. All of those languages have strong static type system. And this is not a coincidence. Even languages that were already popular and are traditionally dynamically typed, so let's say Python, are allocating a lot of resources into developing type checkers and other similar tools that allow them to emulate strong static type system. So in 2022, we can clearly say as a fact, not as an opinion, that statically typed languages has an advantage over dynamically typed ones. Why is it like that? The first answer you would probably hear is that the statically typed languages allow you to change some runtime errors into compile time errors. If we think about runtime errors, they're usually really costly because runtime error is something that can crash your entire system on production. And they require some resources to check for them, and they are not really easy to check for them. You either require your developers to write lots of additional unit tests they would normally not need to write, or sometimes they even require probably unnecessary manual testing. So we can take some of these tests and put it in the compiler. And developers need to write in their code, they need to write the types, and compiler will check that, and doing checking for some common errors, and us checking if we are enforcing constraints of our business domain during the compilation. And if with modern IDEs, developers are receiving constant feedback. Actually, the compilation right now is, for most of the languages, is probably run after every line written. So after every line, the developers will receive feedback if they are not overstepping some constraint of our business domain. Okay, this is the one reason. But there is also the second reason, which I think is as much important as the first one. And I am talking here about type system can be thought about as a immediate, ad hoc, and mandatory documentation. When we have developers working with large, complex code bases, probably every day they are encountering some functionality, they need to use some functionality that they have never seen before in their work. So when they have strong type guarantees, they don't need to read the entire documentation for this functionality. They don't need to understand the entire content of this function. They need to understand the entire context of it. They can just use types as a guardrails that allow them to use this functionality. They know what parameters are accepted. They know what given function is returning. And for some more expressive type systems, they even know in which context this function can be called. And they not only know that, but the compiler will check that for them and make sure they are following the rules. Okay, but so type systems are the great help for the developers. They allow them to be efficient. But I said a moment ago that if they have powerful expressive type system, because not every type system is made equal. They are type systems that are more expressive, and they are type systems that are more intuitive. To show me what I'm talking here about, Let's imagine some abstract example. Let's imagine we are not talking about some function, but let's imagine part of our software system as a vending machine. This vending machine accepts payment with coins and with credit card. So if we want to encode this constraint, what kind of payment is accepted by this vending machine, we can use different programming language. Let's start with thinking about some language with dynamic typing. So let's say Python. In Python, we really cannot, without any outside type checkers, we cannot really say that this payment is anything, or actually enforce any constraint on that in the compile time. So basically, if someone other in our system, the other part of our system is using this vending machine, they can use actually anything as a payment. So for example, they can use twigs and leaves. And right now, I really want you to have this mental image in your head that using dynamically typed languages is like having the vending machine crashing in the runtime because somebody tried to put twigs or leaves into the coin slot. Okay, let's get back to our example. So let's imagine we have something that with actual statically checked type system. So let's take Java. It has a type system, but not very expressive one. So in Java, we probably already have in our system somewhere defined different payment methods. For example, we can have some common interface payment method, and it has different subtypes. Among them, there are coins and there is credit card. So we can say that our vending machine is accepting something that is of type payment method. So yes, so now it will no longer accept sticks or leaves, but and it will accept what we wanted to do, so coins or credit card. But we have a problem that we will also accept other payment methods. And probably we have somewhere in our code base defined payment method that is wire transfer. We have somewhere banknotes. So really, in this case, we also can have crash in the runtime. We are not that safe. We are safer than not having any type safety, but not super safe. Probably we can restructure things like that. So we can add another interface for things that are acceptable for this machine, but we not always has access or allowed to change the definition of already existing payment methods. So this is not perfect. Also, even if we allow to do that, the users always can add additional implementers of this payment method, and we need to take care in the code of this vending machine to somehow support them, or at least crash them gracefully. So yeah, so now let's go to more expressive type system. Let's go to Scala 2. In Scala 2, there exists many ways to achieve actually to discriminate some payment methods and allow only two of them. Two most common, as I think, are using some sealed trade that has two cases that are wrapper around coins and wrapper around credit card and passing them. Okay, that works. The other one requires you some type black magic because it goes like you define some intersection type between two generic types that have contravariant type parameters, and you are using this to encode something that is called union type. And those solution both has its disadvantages. The first one requires you to write boilerplate. You need to create the hierarchy of sealed class. It's only two cases, but it's 3 additional lines in your code that doesn't necessarily brings any meaning, and you feel that they are not really what you want to write. So this is boilerplate. We don't like boilerplate, but it gives you safety. The other one don't require you to write like much additional code, and it also gives you safety, but it's hard to understand. This is a trick requiring some deeper understanding of how type system works. And let's be honest, most of the developers would never came up with this trick alone. Somebody told them about this trick, tell them about how to do that, and they only know it as some kind of secret knowledge. So if I know that some developers are writing code like that and understand that, but if somebody new to the project sees that code and don't know about the trick, there's a good chance that this code will be completely unreadable to them and completely unmaintainable. But at least it is safe. So Scala 2 type system is really powerful, really expressive, but requires you to either know some dark tricks or to write some boilerplate. How Scala 3 looks like in the comparison? In Scala 3, to encode that the accepted payment is coins or credit card, you are just writing that payment has type coins or credit card. And by or, I mean the ordinary or operator that is well understood by pretty much every programmer using any language. This goes completely like natural language when it's intuitive for us to speak that something is this or that. In Scala, it is that simple. In Scala 3, it is that simple. So what Scala 3 have done, it took powerful expressive type system of Scala 2 and make it more intuitive. This is what I talk about, that type system can differ in terms of intuitiveness. So in Scala 3, whenever someone sees the types, just say this type or that type, they will automatically understand what's going on and they don't require any additional training. They will just understand the code. This code will be easy to maintain and our developers will be efficient. And this example with union types is not the only example how Scala 3 made the type system more intuitive. There are lots and lots of other examples. My favorite one, I think, are the match types, which has the exact same syntax as pattern matching. And if one understands pattern matching, they also understand match types because they work basically the same. It's super intuitive practically for everyone out of the bat. Okay. So now we see that Scala 2 have a powerful type system. Scala 3 make it even better with adding intuitiveness. But as we probably know, static typing is cool, but we are living in the world that is nature dynamic. Every bigger system has some point of interaction with something dynamic. Either it is because it is using some database, SQL or NoSQL to store data, it is receiving some JSON queries from the web, or it even is using data frames to perform some Spark jobs. The world around us is really dynamic. And different modern languages, including Scala 2, has pretty much one way of dealing with that. This is a deserialization of that data, also sometimes usually using some form of code generation. And this is also possible in Scala 3, but Scala 3 offers you tools that are much better than that. So Scala 3 has something called selectable traits and improved structural typing. Using the connection of those two, you can create libraries, and there can be created libraries that allows you to work with any dynamic data, offering you the same type safety and the same assistance from the IDE for example, code completion, as you have working with any static types defining local. So these libraries are possible, and there are already prototypes of it. Those are not things that I would say will come sometime in the future. For example, there is already the library called Iskra that allows you for really efficient and really safe, with great assistance from the IDE and support of IDEs, performing jobs on data frames using Sparks. So as I said, though Scala 3 allows you to have libraries that were not possible anywhere else and allows you to work with dynamic data like never before. And it also has everything that Scala 2 has. Okay, so we were talking about what the compiler is doing, but there is other thing, how fast the compiler is doing that. So let's talk about the compilation speed. We were constantly monitoring the Scala-free compiler performance, and we've also run the same test on older version of Scala. And the results can be summed up as follows. Scala-free has the same compilation speed as Scala 2.13. There are some combinations of features in which Scala-free is slightly faster than 2.13, but also there are some combinations of features that 2.13 is still slightly faster. But what we can say for sure is Scala-free is much, much faster than Scala 2.12. And I want to remind you that Scala 2.12 still constitutes the majority of industry. Most of projects still use Scala 2.12. And for this project, Scala-free will be a clear speedup. And the last thing here worth mentioning is that the Scala-free is the only version of the compiler that is being right now actively developed. This means that Scala-free will be receiving performance improvements for many years. That's not for sure. And it will only can be faster, and it only can be faster from now on. And older versions of the compiler, 2.13 and especially 2.12, there is slim chance that they will be any faster in the future. Okay, let's talk about abstractions. Abstraction is kind of scary word. People always, when hearing abstraction, usually think about something complicated, hard to grasp. But I like to think about abstractions as common tools that allows developers for efficient communication. Let's take example of the word function. Every developer and everyone who have anything to do with software development know what function is. But we easily stop remembering that function is also kind of abstraction. In olden days, when people were writing their programs in assembly language, there were no functions. So when they wanted to do something that resembled calling a function, they were just taking all the parameters, push them on the stack, store somewhere the pointer to the point in the code they need to return to, then jump to the place the function code was at, then pop the parameters, execute some computation, push the results on the stack, then do the jump back to the place they should return to, pop the return value from the stack, and continue on. And when the first higher level programming languages appeared, they already had the notion of function. And now we can just say that we are calling a functions, and in the reality, we are doing in assembly terms, we are doing all this operation that I just mentioned before, one after the other, but you can just call it calling a function. And everybody would understand that we are calling a function. We don't need to explain what exactly we are doing. There are, of course, other well-known abstractions, some on the higher level. For example, we can have things like map and filter. When we told the developer that they need to take some data set, map it with this, and then filter with that, this is only one sentence, and then from the get-go, we'll get what we are meaning here. We don't need to explain everything. We don't need to tell more details. They will just get and can implement them. But if we imagine that those words, those abstraction does not exist, and we need to explain the notion of mapping some data set and filtering with something, this will be really hard. This will be really wordy. The developer will need to not only understand all the details, but remember them. This is huge mental burden. So I like to think that abstractions allow developers to be productive, especially allows them to communicate with each other and understand each other's code in an efficient way. But it's the exactly same story as with type systems. Abstractions can differ in expressive power and intuitiveness. So how Scala 2 looked here? I think it was well known to be language with really powerful abstraction, like really, really powerful. But were they intuitive? Let's look at an example of the best known abstraction, or I would rather say the family of abstractions, so implicits. Were they intuitive? First, when we wanted to have some function require some canonical value of some type, we can annotate its parameter with implicit keyword. Okay, what if we annotated that value definition with implicit keyword? This means that we are defining this canonical value. Okay, it all makes sense for now. So, what were implicit classes? Those were used to define extension methods, so something completely different. And what were implicit functions or implicit methods? It depends. It depends. If it had no parameters, it meant that is pretty much the same as implicit value. If it has implicit parameters, that means it is a conditional implicit value. So implicit value will only be synthesized if their other implicit value actually exists in the scope. But what if it has non-implicit parameter? It meant that this is an implicit conversion. So something that is really right now considered anti-pattern. So we really see how these things were powerful and were really useful, but how they were easy to misunderstood and easy to misuse. And as I said with this example with implicit functions, there were three different constructs expressed the same way, nearly the same way. The only difference between them were if the parameters were annotated with implicit or they don't have parameters at all. So with those common sorts of mistakes. So what Scala 3 have done? Scala 3 took all of these abstractions and keep them because they are useful and powerful, but each of them received its own distinctive name that tells its purpose. So for example, if you want to have the function that is using some value, some canonical value of some type, we are annotating the parameter of this function with keyword using. If you want to give this canonical value, we are using keyword given. If we want to have extensions, we are using keyword extension. And if you want to use implicit conversions, I have a bad news because they were so bad, we decided to swap them into the separate trait, and you need to enable them using compiler flags. But this way it is much safer, and there is much harder to misunderstand them and use the wrong abstraction in the wrong place. So here is exactly the same story as with type system. Scala 3 took the already powerful abstractions from the Scala 2 and made them much more intuitive, easier to use, and that means easier to maintain, and costs of maintainers are smaller. But we also added a few more abstractions. So for example, opaque types, context function, and really encourage you to look into them. And they have the same level of intuitiveness as what I just showed you before. Okay, but nobody codes alone, and we don't want to reinvent the wheel every time we are starting a new project. So we need libraries. And how the libraries look like for Scala 3. First, I wanted to say that in Scala 3, you can use 2.13 libraries. So if the library is published for 2.13, you probably can use it with Scala 3. But there are some challenges. For example, if the library has API that is containing macros, it will not really work well. And the compiler will warn you about it and will tell you that. So, but this is not really important because most of the time you won't even need that because the vast majority of Scala 2 ecosystem is already migrated to Scala 3. Pretty much every bigger more important framework is already published to Scala 3. Entire type level stack is already published for Scala 3. Entire Zio ecosystem is already published to Scala 3, and Scala 3 is first-class citizen. And some even argue that in Zio ecosystem, Scala 3 that Zio works already better in Scala 3 than it has in Scala 2. But there is one exception, and this is HTTP. And how sad it sounds, but this is not because of technical reason, but because of legal and business reasons. Because as you probably know, HTTP is no longer truly open source project, and they require paid subscription to be used commercially. And there is no version of HTTP and its derivative libraries that was released for Scala 3.0. So, if you don't want to pay the subscription fee, there is a solution. We were working on helping with migration of HTTP to Scala 3 before we knew that there is the decision that they were no longer going to be open sourced. So we have a fork of HTTP fully working on Scala 3 that is still on the Apache license. So if you need it, we can publish it. And you can use it, at least for the transition period, before you decide either you want to migrate away from the Akka HTTP or use it and pay subscription fee, and then use the release from the official channel. So, to sum up the libraries, the situation in Scala 3 looks like this. For vast majority of projects, there will be no difference at all. There will be no problems at all. All libraries will be already here published for Scala 3. But for some projects, they may probably be some challenges, but they can be overcome. Okay, metaprogramming. Now our next category. There is an old joke among the developers that every single developer agrees that metaprogramming should be forbidden for everyone, except for them, because they need it. And this is true. Metaprogramming is nothing that we like, but this is something that we usually need, and sometimes it is unavoidable. Scala 2 has powerful tool for dealing with metaprogramming needs. It was its macro system. But macro system was infamous for the fact that it was constantly unstable, it was not documented, and it was really hated by the developers because working it was, in many cases, was a nightmare, and you have no guarantees what will work and what not. So Scala 3 took the macro system and published a stable API for it. But this is not what I wanted to talk about here, that our macro system is better than Scala 2 macro system. What I wanted to say here is that the Scala 3 designers realize that most of the times people don't need entire macro system. They don't need to have sledgehammer to swat a fly. They just need simple tools. And Scala 3 has the simple tools. So, for examples, if you want to do some simple operation during the compile time, because this is what metaprogramming mainly is, you have something called inline function. Inline function are just ordinary Scala functions. They don't, inside their bodies, they don't differ at all from the other functions. And they don't require you to interact with some outside special API, but they are marked with keyword inline. This means that this function are guaranteed to be executed during the compile time. And this covers like 90% of the use cases of metaprogramming. I think this and autoderivation, which is also added in Scala 3, covers over 90% of the cases. So in Scala 3, you have macro system, but for simple use cases, you can use much simpler tools that are especially easier to maintain. And as we all know, if something is easier to maintain, it generates smaller costs for us. And the most important thing about this inline example of inline function is that they don't require your developers to have any additional knowledge. They can be used by every Scala developer just doesn't know about them because they are ordinary Scala code, not some special thing like macros were. Okay, speaking about developers, let's talk about their quality of life. So, Scala 3, when it was designed, the designers already have lots of feedback from users of Scala 2 and from users of other modern languages. So they have lots of information, so they can design the language to be as enjoyable to write as it is possible. There's a lot of constructs in the language. So for example, extension functions, top-level function, or this abstraction like I was talking about earlier, that are designed specially to eliminate the boilerplate and reduce the frustration of the developers working with them. Also, there was a lot of effort to make the syntax as streamlined, as clean to read as it is possible. But in reality, I need to be honest, this is what is on this slide doesn't really matter that much. Because there is an elephant in the room, and this is about if we are talking about the quality of life of developers, and this is tooling. Because the developers can be only as efficient as good tools they have. So Scala 2 had and still has an excellent tool. How it looks like with Scala 2, Scala 2 has an excellent tooling, but how it looks with Scala 3. Okay, so let's analyze it case by case. First, we'll start with IDs. We have metals, which is an official language server, and it can be used in lots of editors from NeoVim to VS Code to Eclipse, and it already has excellent support for Scala 3. When you are using metals, when you switch from Scala 2 to Scala 3, you will not notice any difference. The level of support is excellent here. But lots of people are not using metals, they are using IntelliJ. And with IntelliJ, they are still not on the same level, if we say about Scala 3 support, than it was with Scala 2. When I was talking with some company about their effort to migrate from Scala 2 to Scala 3, it was a year ago, I needed to be honest and then said to them that the support for Scala 3 IntelliJ is actually practically not existing. Fortunately, a year later, it is no longer true. It is already good, but it is still not perfect. So we can see that through this year, it improved very, very much. And I think, and I believe that because we are in constant contact with Scala plugin team at JetBrains, and we are seeing their work, and I really believe that this support is good, but in coming months, it will be perfect. It will be as good as it was for Scala 2, at least, or maybe better. If we want to talk about the build tools, the situation here is really simple. All the mainstream build tools, so Gradle, SBT, Mill, Scala CLI, are supporting Scala 3 as a first-class citizen. There is a very good formatter for Scala 3, and it's exactly the same tool, Scala FNT, that we were using before for Scala 2. The missing link here is still the linting. We are working on it right now, and I can assure you that the next minor version of the compiler, so 3.3, will include like things that solve 90% of the use cases of linting that we have in our everyday life. So this is something that is still not here, but we are working hard on it, and you will see results really, really soon. So to sum it up, the tooling in Scala 2 was excellent, In Scala 3, it is already good, but it is coming better. And we're talking about the quality of life of developers, so let's now talk how hard it will be to hire them. So the first fact here is that Scala 2 developers can transition to Scala 3 practically overnight. As I said before, those are languages with the same philosophy, same design principles, and a lot of Scala 2 code is actually proper Scala 3 code. And they can just change the version of the compiler and write their code as they were writing it before, and it will work. They can only introduce new Scala 3, safer, better features gradually. So it don't need to be some kind of big bang migration that can confuse the developers. And I really need to say that overwhelming majority of developers already consider Scala 3 much better, much nicer language than Scala 2, and they really want to work with Scala 3. There is a question of learning materials, and all the new learning materials from now on will probably targeting Scala 3. This means that people that are learning Scala right now will probably be only exposed to Scala 3, and they will consider Scala 2 something quite alien and rather outdated technology. And I think this would result in perception that Scala 2 soon will become a legacy technology. So speaking about hiring opportunities, I think now it is as easy to hire something to work in Scala 3 than it is to hire something to work in Scala 2. But in the future, it sure will be much, much easier to hire someone who wants to work with Scala 3. Okay, so we went through 9 of our 10 categories. And I need to say that in 6 of them, Scala 3 was a clear winner. In 3 categories, there were either no clear winner or Scala 3 offered some benefits, but also some risk or challenges. But now let's talk about the migration itself. Our team have managed to do lots of Scala migration. There were some projects that were open source that we migrated to Scala 3. There were some projects that were big enterprise code bases. There were some projects that are now running on the production using Scala 3. There were some projects that migrating them to Scala 3 was pretty painless, and basically we just changed the version of the compiler, ran the build with some very little small problems, but those problems, to fix them, we needed to tweak like one file for every 10,000 source files. But there were some projects that were challenging, and we need to rethink in some places even the design of the system itself to migrate it easily to Scala 3. And we sometimes spend weeks on single problems. But most of the cases, the migration was really painful. So if anybody asks me a question, is migration to Scala 3 easy? I would say it depends. Every single project requires an expert to do cost and risk assessment for given migration. And this is why we are here. We as a VirtusLab are offering completely free of charge, without any strings attached, migration support for Scala 3. We offer you our risk and cost assessment, expertise, and help with migration itself. You may asking us why we are doing it completely for free. What's the benefit for us? And my answer was on first of my slides, because we are the company behind the Scala 3. So in our interest is the health of entire Scala ecosystem and the growing popularity of Scala in the industry. We are treating this as an investment in the future, investment of our and yours future as well. So I hope I give you some necessary information to think about migration to Scala 3. And you will contact us and we will be able to work together. Thank you. So I think we may have some questions.
Yes, I think we should have some questions. Thanks very much, by the way, Paweł. That was very insightful, really good information being shared there. We've had a few questions, and I'm just going to start from the very top and try to dovetail them in together if we can. So Scala 3 doesn't have support for macro annotations. Are you aware of any projects that are relying on them?
Yes, this actually came, I actually seen it in replies to one of things that are posted on Twitter that, for example, I think Spotify is using macro annotations heavily in their code base. And this is true. There were some, I would say, controversial feature of Scala 2 that was not supported when the Scala 3 came out. But this was not like a decision that we don't want to have macro annotations in Scala 2. It was more something that we don't have clear, good design for them, and they can be added later. And the situation like this right now is that we can achieve lots of things that were done by macro annotations with simpler means in Scala 3. Not all of them, but lots of them. Auto-derivation is a good example, that feature that is replacing some use cases of macro annotations. But of course, it would require sometimes serious work. I don't want to say for all the projects that have macro annotation that will be a lot of work, but for some it can be. But there is good news for this project, because starting in Scala 3.3, so I would say next 2 or 3 months, 2 months, I think, we will have feature draft for the new macro annotations. So this is a draft phase of the feature, so it needs to be enabled for the project, but it will give you the preview how the macro annotations will look like, so you can start thinking and experimenting about the migration then. So it is really soon, I think. But maybe for the design of your system, it could be better to use something other. But soon you will have a choice. So macro annotations are definitely coming soon.
Brilliant, thank you. I have another one from Anna. Should I wait with the migration plan until tooling is optimized instead of starting work on it right now?
Yes, this question will be always asked, I think. And I would say for that I see lots of activity right now with projects migrating to Scala 3. For example, 2 days ago, I've seen a tweet about, and I shared it, about the Lichess, so this online chess engine that migrated its entire code base to Scala 3 right now. I've also received some information about the companies that we haven't known about and we haven't talked with them that have done the migration themselves. So basically, I see that Scala is gaining traction. So there is critical mass right now. People started to realize that tooling is already so good that they can work with that. And also, there is one additional aspect thing here, I think, that if you are migrating now, and especially if you contact us in this matter, we can have some cases for your code base. It happened in the past that there were companies that have some special cases in their code base, and we somehow influenced like some inner workings of the compiler. So this case, we are sure that it is working exactly as efficiently as it is intended. And it happens sometimes in the past, and especially we're finding bugs in the compiler that were causing some problems for this project. So if you start migrating right now, you may be sure that the sooner the Scala 3 will be much better for your project. Because for example, contacting us or even using GitHub for reporting issue, you can influence how Scala 3 is evolving. So yeah, so I think it's sooner the better. And now I think the tooling is already good enough.
Good answer. Thank you. Thank you. We have just sort of tied to the sort of whole Scala 3 story and where we're going with it. Kolja has asked a question. Do you guys have hard facts and numbers around Scala 3 and how successful it is and how the technical features are being taken on board? Like are there more Scala projects, more development programs? Are there more customers and use cases? Just general adoption of it. Do we have evidence of that and hard numbers?
I don't have unfortunately, I don't have hard numbers right now. We started collecting them and seeing how many companies are using Scala 3 and using it on the production. I think you can look at download stats of many Scala 3 frameworks, so you can see how it looks like. But it is also worth remembering that even some projects that are already migrated to Scala 3 are also cross-compiled to Scala 2 for some safety reason, for example. They wanted to be safe for now, I would say. So they will still also inflate the Scala 2 download rates. So you need to keep in mind in comparing them, but we see steady increase in that number. So no, I cannot say exactly in the percentages of industry projects that I migrated. But if you want hard percentage, I want to tell you that year after the launch of Scala 3, there was a survey among the Scala developers, and 40% of all Scala developers already were working in at least one project that is using Scala 3. So it's a big number.
Okay. I'm going a little bit deeper on that from Kolja again. The example he's trying to give is, like Rust, has a very strong adoption in Linux kernel dev. Or Python extension writing, but then Python has a very strong foothold in ML and data science. Is Scala or Scala 3, does it have a strategy or an area in particular that it wants to target, either classical or back-end or data engineering? Where would you say that was?
Oh, there are a few actually. First of them I would like to think is something that Scala already excels at. So large ecosystems that you need lots of safety. So I am thinking big financial systems. I know about many large banks that are using Scala for their backends. So this is one of them, because I don't think there is another language that will give you this level of safety as Scala is giving you, and this level of productivity, because for example, you can be really safe with Rust, but as I love Rust, it is not a language that you can be as productive as in Scala, or at least it is much, much harder. So this is one. The other is data engineering. For example, Apache Spark. And I can see the question that we have a question if Apache Spark is supporting Scala 3. So yes, as I mentioned during my talk, there is a library called Iskra that allows to, it is still not yet production ready, but it's going in that direction, that allows you to write Spark jobs in the safer way using Scala 3, but you can do that like you were doing it in Scala 2 already. Apache Spark engine itself is published using 2.13, and it can run jobs created with Scala 3. And this is the other dimension, so data engineering and especially Spark, that I think Scala is a really good choice for that. And this also has this benefit that Scala is really good for working with the dynamic data, because data engineering is usually about some kind of dynamic data. There were other experiments. For example, there is a lot of effort put into Scala native, so we can have really lightweight applications in Scala that can, with really small footprint, that can be used, for example, as lambdas on some cloud. But this is something that we'll see in the future if there is adoption this way. I believe in that.
Thank you. Great answer. I have a question from Lene, which is, how about static application security testing? How does that work within Scala 3?
So I'm not sure if I'm getting exactly what's here. But if we are saying about using static analysis to find security problems inside of applications, I think Scala is excellent language for that. Firstly, because we already have the safety guarantees on JVM, because most of Scala programs are running on JVM, so it is already something. We already have memory safety, something that other languages needs to care about. We have it for free. And about static analysis, as I said, Scala has one of most expressive type systems out there, so we can encode constraints about our business domain, like in no other language, and these constraints are checked during the compilation time. My favorite example of something that is not really encodable in Java or any other mainstream statically typed languages are path-dependent types, because in other languages we cannot really encode. And it is not checked during the compilation time that sometimes depending not on just other type, but for specific instance of this type. And we cannot pass any other instance here. So I think using Scala type system, we can encode some constraint, and this constraint can be about safety as well. And they are all statically checked. So
Brilliant.
This is what I would answer.
Thank you. I'm trying to go through the questions as they have come in, but also try to relate it to the conversation. This one's a little bit left field, back to frameworks really. Do we know if the Play framework is currently supported in Scala 3?
I don't know about. I don't think so. That is already supported. We were talking about migration with some project that was using not really extensively Play framework, but they were using in some smaller scope. So we arranged it in that way that they can isolate it to some module. This module is still compiled with 2.13. And as I said, if you create your own 2.13 module, you don't have these challenges with using 2.13 libraries. So basically, they can use it from Scala 3. So in this case, and it was a few months ago, they arranged it in such way that the Spark was called from separate module, and this module interacted with the rest of the application, which can be migrated to Scala 3. I don't really know what the plans for Play framework are right now after this entire story with Akka HTTP, because Akka HTTP is the foundation of Play framework, because they changed the license. So I am not sure what their story will be and what exact plans they have about Scala.
That came from Rolf, and I think what we can do is keep an eye on that and feedback some information to you when we get it. So yeah, that was a good conversation. I mean, we've got another one about Apache Spark support, but I think you've covered that one off. We've got from Wale, is there an online guide that talks about migrating Scala 3 to Scala 2 currently available?
Yes, it is easy accessible from the main page of Scala language. It even shows some automatic tools that can rewrite, that can do trivial rewrites of your code, so it will be more idiomatic for Scala 3. But yes, there is a guide, and it's exactly saying one by one which feature will not pose any problems and which requires some attention.
Okay. Also, there's a question from Bjorn, more of a statement and a question, really. He thinks that Scala is a really nice language for learning computer science and software engineering, but it seems like many universities currently are replacing Java with Python. That is very true. I do see that a lot myself, especially in the introductory computer science courses. But do you have a feeling that Scala 3 can help in the adoption of Scala as a teaching language in the future?
I think that Scala 2 really wasn't a good teaching language because it was not that simple. As I said, it was not intuitive, and we should teach people programming using intuitive language. This is why many universities are now using Python. But I think Scala 3 is much better in this regard. I would say all this intuitiveness of type systems. So, for example, that for many people, notion of what I use as an example in my talk, union type is something obvious. We understand what it means that something is this or something else. And this is like not really easy to encode in Java. It is not encoding at all in Python because normally in Python we don't use types. And this intuitiveness that this can be easily encoded in Scala, I think will help in adoption of Scala as a teaching language. Also, the tooling is important, and I can see that there are tools right now. They are both some of them are both for Scala 2 and Scala 3, but Scala 3 was the reason that they are there. I'm talking especially about Scala CLI. Are good for newcomers to easily start prototyping things with Scala 3.
Right. So therefore, if you've got anyone learning languages, get them on Scala 3 and see how it goes. So we've got a question from Mitchell. He feels that migration is well supported for applications, but when it comes to cross-building libraries, the result won't be Scala 3 idiomatic without duplicating lots of code, especially around implicits, i.e. given. Will this improve in your view?
I can't promise much about this. Yes, I understand the problem that lots of libraries, of course, they are still released and still published for Scala 2, but we need to keep some kind of compatibility. So this is the reason why, for example, implicits are still legal in Scala 3. We have a better abstraction for them, better keywords for them, but you can use implicits, so your Scala 2 code is still proper Scala 3 code. So this, I think, is not a technical issue. It's more like, I would say, social issue, because we need to still maintain the libraries for Scala 2. In the future, when I hope Scala 3 will be adopted by all, we will not have this problem. Yeah.
Brilliant. So at the moment, I can't see any more questions coming across. I just want to check that we've answered them all. I think we have. We've got a little bit more time. So if anyone's got any burning questions for Paweł, now would be the time. Okay, another one from Bjorn. When do you think Scala Native 3 will be production ready?
It really depends what you mean by production ready, but I think there is really amazing stuff happening in Scala 3 right now. And this is a lot of resources invested in Scala 3. For example, one of my teammates, Wojtek, is working hard right now on the safe model of concurrency in Scala Native, and it is practically ready. And I think this will be a huge milestone into being able to call Scala Native production ready. So yeah, but I think it is already stable for some time. But I hope I will soon be able to assure that it is 100% production ready. So the answer is sooner than later.
Okay. So we still got a couple of minutes. If anyone's got any other burning questions. Okay. How does VirtusLab position itself in marketing the language to make it more popular? Will there be conferences? Really love this talk. That's really good. Thank you, Colin. Thank you.
Thank you.
What do you think? What can we do to help build it up as a business and for the community?
Yes. So first and foremost, we are contributing to an ecosystem. We are creating libraries. We are creating tools. I show you 4 examples of tools we are working on. And as I said, we are. As this was asked here, we are showing ourselves at conferences. For example, there were 6 speakers at the last ScalaCon from VirtusLab, and we have our own conference here in Krakow called Sphere IT. So basically, you can also meet us there. The last edition was, I think, this October, so not long ago. So yes, so this thing is our main contribution to the language itself and its more popularity. Also, we have a plan, and we are starting slowly to do that, to appear on non-Scala and even non-JVM conferences. For example, there is, as I said, we really hope that Scala will be used in data engineering. So we are already sending our submissions to data conferences. We wanted to show how data engineering can be efficient and especially safe using Scala. So yeah, so we hope this will make Scala more popular, and this will contribute to the entire ecosystem.
Thanks. Good answer. Yeah, and I could speak for that in terms of VirtusLab's kind of, vision for this and our contribution. We're expanding as a business. We've got operations in Germany, the UK, in London particularly, Switzerland as well. We've opened some new regional offices in Poland, and we're very much about the community and sharing our knowledge and really getting and upselling this capability. So that's great. I've got another question. Okay, yeah, so thank you for doing the non-GM conferences. He really likes that idea. This is one from Bjorn.
Yeah.
Will Scala be viable for Android app programming?
This is a hard question, because I don't like to say that, but I need to say that Android programming is not really our priority. Of course, I believe there are many people that would like to use Scala for Android, but this is huge cost to maintain the libraries community. And I think Kotlin is close to Scala in the terms of syntax and overall feeling. Of course, Scala is better. And I am saying this as a person who came from Kotlin tooling to Scala tooling. But I think this niche is already taken mostly by Kotlin and would require enormous effort from us to really fight for it with Kotlin. So I don't think it's our priority. I know that there are some open source projects, some open source activity, but it is not something I would say coordinated or like big endeavor.
Okay, great. Thank you. Chanyuka sent a message. He believes there's been a trend towards using Spark in data technologies like Snowflake and Databricks. How do you see the inclination to Scala 3 in data engineering? I know we've covered that off a little bit, but would you be able to expand a little bit more as to where you see that fitting in and how that might come to pass?
So as I said, in data engineering, Scala allows you to be efficient. Of course, it is a language that is slightly more efficient in Python for many cases, but for Spark, when a lot of things are done natively, I think it's not really like super important, the language that you are writing your jobs in, but it offers you better safety and better efficient for the programmer, not for program itself. So I think you can be much more productive developing these things in Scala. So I think this is what Scala can bring to like the big data.
Brilliant. Thank you. Thank you. So yeah, we've still got a little bit more time. If there's any other questions, that would be great. If not, then we can call it a day. No, we're looking good. We're looking good, Paweł. I think you've managed to answer everyone's questions, and really good answers, great insight. Everybody, thanks ever so much for spending the time. Keep an eye on LinkedIn and social media, our websites, our Twitter feeds. We'll be doing a lot more events covering a number of different sort of paradigms, because we do cover a lot of areas around the open source and cloud native. Feel free to reach out to us on LinkedIn if you want to have further conversations. And we look forward to seeing you at either a live event or a webinar event in the future. And Paweł, thanks ever so much for your time. It's been excellent. Thank you.
It was a pleasure. Thank you all.
Have a good evening, everyone. Take care.
Bye.